lesson 4A, we're going to look at angles and congruence of triangles. We're going to start with a couple of theorems about our triangles and the measures of their degrees. We developed these during a lab in class, so we're just going to consolidate that into notes here. We have the triangle angle sum theorem. So the angle sum theorem specifically for a triangle. This is only for triangles. It is that the sum of the measures of the angles of a triangle is 180 degrees. For example, with this triangle, with angles A, B, and C, the sum of those angles A plus B plus C equals 180. We also developed in class the exterior angle theorem. This states that the measure of an exterior angle of a triangle, okay, so for instance, this exterior angle, which is formed by extending a line out, this would be exterior to angle C, is equal to the measures, the sum of the measures of the two remote interior angles. So this is the adjacent interior angle. The angle exterior to angle C will equal the sum of the other two. These are our remote angles. So in this case, angle A plus angle B. So those are the two theorems that we developed in class. They're going to introduce a concept we're going to work with in our next class. A few concepts. We have, first of all, congruent figures. So figures, any polygons, we're going to start with triangles, that can be mapped exactly onto another geometric figure are congruent. So in other words, if I had this triangle and I have another triangle, if this triangle could map perfectly onto that triangle, then they would be congruent. Even if they're not on top of each other at the moment, if they would match up exactly, that's through rotations, translations, and reflections. As long as they would map onto each other, they are congruent. And two congruent triangles are going to have all sides and angles, corresponding sides and angles be congruent. So if I were to label this A, B, C, and A prime, B prime, C prime from some kind of translation reflection, then I would say the side AB is congruent to the side A prime, B prime. And the side BC is congruent to its corresponding part, the side B prime, C prime. And the side AC is congruent to its corresponding part, A prime, C prime. Additionally, triangles have 6 parts, 3 sides and 3 angles. Angle A will be congruent to angle A prime. Angle B, we'll use 2 here, will be congruent to angle B prime. And angle C will be congruent to angle C prime. And it doesn't matter which one gets the single mark and which one gets the double mark or the triple mark, as long as they match. So if this were 1 and 1, that would be fine, but this part is not congruent to that part, so I don't want to match up the wrong ones. So our corresponding parts are our matching parts. They're in the same relative position. Okay, so congruent figures, two figures that can be mapped onto each other. The corresponding parts are the parts that are in the same relative position. So in this case, my base is AC. To the right of AC is BC. To the right of A prime C prime is B prime C prime, and so forth. So this leads us to 2 more theorems. And these are, this first one we abbreviate CPCFC. You can also use, this is corresponding parts of congruent figures are congruent. This is the generic version that can be used for triangles, rectangles, octagons, nonagons, decagons. But we could also, just when we're working with triangles, sometimes it's a little bit easier to say CPCTC, and you will see that as well. And that's just the very specific one for corresponding parts of congruent triangles. So you can always use CPCFC when we're dealing with triangles. You could also use CPCTC. But it's just a theorem that says corresponding parts of congruent figures are congruent. So if I'm told, for instance, that triangle ABC is congruent to triangle A prime, B prime, C prime, then I know that oops, wrong color. I know that AB, these are the first two of the triangle, is congruent to A prime, B prime, the first two of the second triangle. Oh, I didn't change these right here. There we go. There we go. And BC, those are the second two, would be congruent to B prime, C prime. And AC, the first and last, would be congruent to A prime, C prime, the first and last of this triangle. And similarly, angle A is congruent to angle A prime because they're the firsts. Angle B is congruent to angle B prime because they're the seconds. And angle C is congruent to angle C prime because they're the thirds. Okay? In notation, we'd say A is congruent to A prime, B is congruent to B prime, C is congruent to C prime, AB is congruent to A prime, B prime, BC is congruent to B prime, C prime, AC is congruent to A prime, C prime. All right, so that's just matching, saying these parts match, whatever those matching parts are. And then finally we have the third angle theorem. This is a special property just with triangles that tells us if two angles of a triangle are congruent. So if I'm given, for instance, that C is congruent to K and B is congruent to J. So I'm told two pairs of angles are congruent. Then the third pair of angles will also be congruent. And if you think about it, it makes sense. Whatever the value of C is and whatever the value of B is, because C plus B plus A equals 180, if these are the same values as these two, then A will have to be congruent to L. So this is just a quick shortcut just for angles. If two pairs of angles are congruent, then my third pair of angles is also congruent. So those are the reference notes for you to have down. We will go over how to use these together in class with our guided practices and independent practice. Make sure you have those. Everything I wrote, you should have written, and then I will see you in class. Have a good day.